Hi, Catherine.
Oh, Chaka, hello. I wonder whether you could talk through some of the ways in which you've worked when you've planned with a maths teacher in the classroom with EAL learners, because obviously they might need to rethink the way they plan a lesson when they've got EAL pupils in the class.
Okay, well, I've got an example of some work that I did in a school here. The first thing that I thought was that because everybody in the department was already familiar with this sort of broad outline for planning, I didn't want to change things too much. And so, because the way in which they like to express their learning objectives was through the Walt and Wilf system, I kept with that, and I tried to not match exactly the learning objectives with the outcomes for the students, but make sure that those things were taken into account.
So how do you make sure that the teacher actually has a focus on specific language features in that structure then?
Well, I think I tried to work backwards from the outcomes, what it was they wanted the students to produce in the lesson. So I thought, well, okay, if the teacher has a clear idea of what it is they want the students to be able to write or write about, then they will need to plan for this beforehand. So they'll need to think about the vocabulary, but it's not just all about keywords, it's also to do with the connectives that structure the writing and also the other structures, the language functions. So what purpose is the language fulfilling in that piece of writing? So working backwards from there, they needed to think about the language that the students were going to use to be able to demonstrate that learning and access the content. And then going backwards from there, it was what did we want the students to be thinking about? What did we want them to be talking about? So again, the emphasis was on, of course, them completing the task successfully, but language was a crucial part of that.
So you're sort of starting from the learning objectives, you're adding in the language objectives in order to achieve it. Yeah, I mean, that's very similar to the type of planning I've done, not specifically for EAL advanced learners, but for pupils learning a language in a subject context. And again, always starting with the learning objective, then with language objectives, and adding the sort of vocabulary later on in order to achieve those language objectives. But I wondered whether you've ever sort of been much more explicit about the actual sequence of the lesson. Have you ever tried to do that? Or, for example, I've highlighted you start with some context setting, and then there's a phase where the teacher must do some modelling, because that's obviously so important to show the aim that they're trying to produce a particular type of language.
I didn't set out that teaching and learning cycle as explicitly as you did. The school was already very familiar with setting out the different episodes in the lesson. Those episodes tended to be of a similar type, so lessons were structured in the same way. But yes, within that, teacher modelling, for example, was a very important part of it, because that was where the actual structures of the language that they were going to use were being shown to the learners.
And also, I guess, group work, that, you want them to do some interaction in the lesson, you might also want to highlight that as a particular stage in the lesson.
Absolutely.
Okay, thanks. That's good.
Thanks.
Hello, I'm Catherine Driver, a consultant for the EAL Academy, and this module is aimed at supporting teachers of mathematics to understand how best to work with more advanced EAL learners in their classrooms, in mathematics classrooms. And in this session, I'm going to introduce some theory and some teacher learning strategies for EAL pupils, and my colleague Chaka Amadi is also going to make some contributions, particularly looking at vocabulary and word problems. So overall, this session is going to look at the needs of pupils learning mathematics in a second language. It's going to introduce some of the particular features of mathematical language that might be a barrier for the EAL learners. We're also going to review some interactive teaching and learning strategies for EAL pupils in maths lessons, including reading word problems, which is a particular issue for these students. The advanced EAL learners that we have in mind for this piece of work are those who are developing competence in English or who are nearly competent in English. So they can probably express themselves very well orally in English, but there may be a few structural inaccuracies in their speech and more often in their writing. Generally speaking, these pupils have had previous education and are already able to understand many of the concepts of the maths lessons. They've learnt maths before, but they would have particular difficulties with some of the more specialist vocabulary and some of the more complex reading and writing problems in maths. So, as well as linguistic barriers for EAL learners, there are quite often cultural barriers for EAL learners. For example, in some countries they don't cover in the secondary curriculum the same aspects of maths that are covered in the UK. In many countries in the Middle East, for example, students would be unlikely to have studied topics around data management, data statistics and probability, but they would be very competent with algebra and geometry questions. In addition, another particular cultural barrier might be the type of books that they're used to using in their lessons. We tend to have maths books with a whole range of illustrations, diagrams, pictures, charts, colour, different fonts, which can be quite difficult for students who've been educated in other parts of the world where textbooks are just in black and white with a few line drawings. Obviously, the other barrier that can affect these pupils would be the actual educational level that they've reached. Sometimes pupils with EAL who are late arrivals into the UK education system will have missed several years of education before they actually reach this country and may not have covered the same topics that we would expect, say, a year 8 or year 9 to have covered in England.
Hello, my name's Chiaka Amadi and I'm one of the consultants at the EAL Academy. I want to talk a little bit about vocabulary and how you teach it to advanced learners of EAL in the maths classroom. The first thing to point out is that students who have either been studying in this country for some time or who were educated in their home countries will already know a certain amount of mathematics. And although as teachers we might be very preoccupied with the individual items of vocabulary, very many of the mathematical words that we are worried about, the words that which seem very long and very difficult, the technical vocabulary, is actually some of the easiest vocabulary for the students to learn, because words like mathematics are very similar in a whole range of languages. So words that come either from Latin or Greek tend to be the same whichever country you're living and studying in. So for example, the Spanish word for mathematics is matemáticas, the Lithuanian word for mathematics is matematikos. So it's important to remember that and not spend too much time worrying about the technical words. It's actually much more important to think about the words that relate to the different topics in maths. One of the techniques that I have used in the past for helping children to learn new mathematical vocabulary is to start off a topic by looking at all the key words that are likely to come up. So, for example, make a list that relate to the topic and see how many of those words are already familiar to the students. See how many of those words the students might have heard of but might not necessarily know the exact meaning of, and then how many of those words the students know very well, can explain, and can even give a definition of. Using this technique, it's very easy for the teachers and the students to know where they need to concentrate the teaching, and in so doing they can help build up that student's familiarity with the vocabulary. Another technique that teachers might want to use is in teaching definitions, rather than give students a word plus a definition, is to split those up somehow, so that the teacher will give students a series of cards that will have a definition and a key word on them, but those definitions and keywords don't actually match. In that way, when a student reads out a definition, everybody in the class has to listen to see if they have the key word. The student with the key word will then give the key word as the answer, and it's then their turn to read out their definition. Those sort of loop games, or follow me games as they're called, are really good not only in developing vocabulary, but in developing confidence, in developing listening skills, and in developing speaking in English. As well as looking at ways of getting children to practice and rehearse vocabulary out loud, orally, I think it's also important for teachers to look very carefully at the way in which vocabulary varies, perhaps in examination questions. For example, when looking at a series of questions to do with money, with a Year 10 class, we found that words like wages, salary, expenses, expense, expenditure, which were all very similar but all had very slightly different meanings, caused some confusion. So again, what we did with that was we looked very carefully at the list of words and organised them in such a way that the children would be able to try and pick out for themselves the similarities and differences. And we did that by setting them in context. So rather than teaching them as discrete vocabulary items, we set them in context, and it was the job of the children to decide whether they would rather have wages of £50 a week or a salary of £50,000 a year, and so on. It's really useful for the students to be able to experiment and play with language and its meanings in a realistic context in that way.
We're going to look at some of the language features of mathematical language, which are very specific to the subject. First of all, you need to think about the language functions in maths, that is, the uses of language in maths. For example, one language function that is very common in maths lessons is that of comparing. Pupils might be comparing the size of objects, or they might be comparing whether one thing is older, cheaper, faster, slower than another. That is a typical language feature that would come up in maths lessons. Another type of language that you would expect to hear in maths lessons is the language of making a prediction. For example, if you double a number, then it will be the same as multiplying by 2. Mathematical language has particular language features that may be difficult for EAL learners to access. One thing that you notice when you read maths questions or maths textbooks is that most of it is written in the present tense. We use the present tense in maths. It's called a timeless present tense because we're talking about universal truths or facts. Another aspect of mathematical language that is helpful for teachers to look at and think about is that of the language functions. That's how we use language in maths. Some examples of the typical functions in maths would be comparing, predicting, defining and classifying. For example, with comparing, even small children get used to saying this box is bigger than that box, or give me the fastest car to play with. So comparing is a very typical language feature of maths language. The other aspect of maths language which teachers are always focused on is that of vocabulary. So I'm going to introduce a few strategies that are really helpful for EAL learners when they're trying to build their confidence actually speaking particular aspects of mathematical language. And one that we mentioned earlier was the language of comparing. The strategy of using a follow me or loop game, which is good for vocabulary, can also work well for sentence level. This example here is asking pupils to listen to questions about decimals, whether they are larger or smaller than each other. And we have a complete set of questions suitable for a whole class, asking things like, you are 400ths smaller than 0.94, or you are 3/10 greater than 0.29. So the pupils have to listen really carefully to the mathematical language hundredths and tenths, and they also have to listen to the words greater than and smaller than. And as they hear the questions go all the way around the class repeating the same structure, it helps them actually learn to say it correctly themselves. So you have a complete set of cards for up to 24 students here. So that's a follow me or loop game. The second strategy that also helps pupils to think about comparing is a true and false strategy, where you give students a number of statements, in this case about fractions, decimals and percentages, again asking, is 3/4 greater than 5/6? Is 0.5 the same as 4/8? Is 2/3 smaller than 75%? And they have to discuss in pairs or even in larger groups whether they think each statement is true or false. Again, using comparative language in the discussions, so that a more expert speaker of English will be modelling how to use the comparative language to the EAL learners in the class who they're working with. The third strategy helps students sequence activities or events or even questions in maths. And the example here is a set of instructions to sequence after observing a demonstration of how to construct a triangle. And you can do it two ways. Pupils could number a set of sentences in the correct order, like the one you can download or see on screen. However, the best way of doing this is with a set of cards cut up so that the pupils can actually manipulate the cards and move them around. This means that they don't get so stressed about being wrong. If something is wrong, you can move it around quite easily and see that you've got the correct sequence. If you do the print version, it tends to lead to a lot of crossings out and arguments. So I generally find the card version works a lot better. And in this case, if you look at the example that you've downloaded or that you're looking at on the slide, you will be able to see that we've highlighted particular words in the sentences. In this case, words like another and the other and the end of the line or another end of the line. So it's highlighting an aspect of language that advanced EAL learners might find difficult in sequencing a set of instructions. So all of these are activities that maths teachers could introduce into their classrooms to help extend the more formal aspects of mathematical language with advanced EAL learners. One of the strategies that works really well for the more advanced EAL learners in maths is to get them to work in groups on a word problem. These pupils probably speak quite fluently and confidently, but need a lot more practice actually using mathematical words in context. And word problems are a very useful context for them to practice. So what you can do is put pupils into groups with specific roles, and you would give out a set of role cards, for example, chairperson, recorder, clarifier, and in this particular case we have a role for a language listener, so somebody in the group actually has to listen to the maths words and phrases and record examples of the pupils actually using the correct vocabulary in context. So they work in a group on completing a maths question. For example, these are GCSE questions about pie charts, and at the end of the piece of work where they've worked out the answer, they're then expected to present their answer to the class, and you can see an example of a worked piece of maths that a group of students did on these very questions on pie charts, and they were able to stand in front of the class and present their answers, having worked collaboratively. So it's the collaboration that enables them to reach a higher level.
Another activity that you can do to help children with the reading of mathematics questions is to give them a reading grid. The one that I've got here is A4 in size, but it is also useful, particularly when students are working in groups, to blow it up to A3 in size and then laminate it, and students can then write with erasable pens. What we do is we pin the question, and I've got some maths questions here, pin the question to the top box, and then the students work through each of the boxes on the left hand side, which give them specific instructions about how to read the question. So the first box tells them to read the question out loud. The reason that that is helpful is that it gives them the chance to actually hear the word and reminds them of the sound of it and reminds them of their familiarity with the word. After that, they highlight any words in the question that they've not come across before and find out the meanings of those words. And they can do that either through talking to the other people in their group or through looking things up, perhaps on the learning wall that's in the classroom, or through other sources that are available to them. They next need to pull out which words have a very specific mathematical meaning, and that is going to help them decide which mathematical processes they're going to be involved with in doing the calculation that underlines the question. They also identify any cue words. These words could be things like percentage or proportion, things that give them an idea about whether they might be, again, multiplying or they might be dividing, the different mathematical operations they might be using. Finally, as they work through the questions, they have to think about and predict what kind of solution they're seeking. The reason that that's important is that very often students will, because they're numerate, start doing a mathematical task, complete a number of operations, come up with a number, and because they're not necessarily holding all of the words of the question in their heads, might go off at a tangent and complete a number of mathematical computations that aren't actually relevant. So it's really important before they start actually calculating that they have some sort of idea of the kind of answer they're looking at, and it will give them an idea of whether or not they're on the right track. They work through all of these questions, and there is space on the right hand side of the grid for them to write down either the words that they need to make the notes and then to do the calculation and finally arrive at their answer.